I'm Mr. Richmond, and this is your Unit 10.2, 10.3 lesson summary. Unit 10.2 and 10.3 was on frequency distribution, relative frequency distribution. We'll do some work with some stacked bar graphs, and then we'll take a look at relative frequency conditional distributions. It's a mouthful, but difficulty-wise isn't too tough. So this will really be a brief summary. You're going to need to go through some of the problems in the book to get a better idea of how to do all this. I'm just going to briefly talk about the differences between these. You can work out the examples I have here, but because of time's sake, I have all the math already done here, and I'm just going to really explain the process. So for all of these, I'm going to start with this data. I have data for favorite movie genres for men and women. Men in the survey, there were 66 who preferred comedy, 41 drama, 133 preferred action, and they surveyed 240 men total. Women, there was 177 who preferred comedy, 110 preferred drama, 48 preferred action, and there were 335 women total in the survey. And then down here I have the total of all those. 243 in total preferred comedy, 151 in total preferred drama, 176 preferred action, and there were 575 people in the survey. So the first thing I would do here is create a relative frequency distribution. Because these numbers are nice, it does show me that majority of people preferred comedy, less so drama and action, but it's nice to think of it in relation to something. What percent of men prefer comedy? What percent like drama, etc.? And that's what we do in a relative frequency distribution. We'll have men, women, and a total line, or categories, comedy, drama, action, and a total column. And we're going to do the percent in a relative frequency distribution, percent in a relative, based on the total of all the people in the survey. So your bottom right column number should be what you're dividing by. So you'll notice in every single one of these I took, for this one, 66, divided it by 575, and then converted it to a percent and rounded it to the nearest 10th place for that. Depends on what your teacher wants for that problem or what the problem's asking you. For this example, I rounded to the nearest 10th of a percent. And then the next one would be 41 divided by 575, which is around 7.1%. 133 divided by 575, which is 23.1%. And I just continued that for each of the numbers in the table, dividing each of them by 575 and converting to a percent. Takes a little while, it's a little bit tedious at times, but as long as you're careful, you're checking your rounding and you're good at converting a decimal to a percent, it's not really too difficult. So if you want to take a second and try that, you can pause it and work these out yourself. If you get the idea, we can just move forward from here. So from that data, I can kind of start to identify the highest percent. The highest percent looks like it was 30.8, and that was for comedy. Women that preferred comedy had the highest percent of the total people surveyed, etc. Now I can try a new bar graph. It's called a stacked bar graph. Usually when you create a stacked bar graph, it's not based off the frequency, like the number of items I had, but the percents. So for this one, I wanted on the x-axis the genres, comedy, drama, action, which means my other categories need to be my bars. And I need to make a key. So it's real important to remember to make a key. I made a dark bar for women, a unshaded bar for women. Dark bar for men, unshaded for women. And I have my dark shaded bar for comedy for men going up to approximately 11.5%, and then I can end that bar there. Then I stack on top of it the women percentage, 30.8, and what's important is a common mistake is the length of the bar is 30.8, which means when added to the men's bar, it brings it all the way up to the total, which was 42.3%, which is why my bar is coming all the way up there. So that's how you do a stacked bar graph, and I would repeat that for the other ones, drama and action. Drama, up to 7.1 for men, adds another 19.1 for women to reach a total height of 26.3. 23.1 bar for men, action, coming to here, adding another 8.3 bar to that gives me a stacked bar total of 30.6 for action. And then I wouldn't put the totals on the bar graph, obviously. And this kind of just makes it a little more clear. I can see based on the percents, majority preferred comedy. Men, I can see preferred action the most. Women preferred comedy the most by the lengths of the bar. So it's just a little easier visually to see. One other thing I might want to do is a relative frequency conditional distribution. You need to know the difference between that and a normal relative frequency distribution. Our additional word is conditional because we're only going to find the percentages now on its own personal condition or category. So rather than doing everything over 575, the total, you'll see that the total line is completely removed, and I'm only going to do the percentages based on their own category. So I want to know what percent of men prefer comedy, not what percent of everyone. What percent of men like drama? What percent of men like action? What percent of women like comedy? What percentage of women like drama? What percent of women like action? So I'm taking 66 now instead and dividing it by the total of my men, 240, 240, 240. And taking my women total, 177, dividing it by the total of women, 335, 335, 335, 335, and getting the percent. So you can see my percents here. And so when I look at it this way, it might give me a little more detailed information as far as what men prefer. And looking at it this way, I can clearly see that men prefer action the most. Over 50% of men prefer drama. The one they least prefer is they prefer action. The one they least prefer is drama. For the women, it's clear over 50% prefer comedy, whereas their least is action. So obviously that doesn't work real well for date night when you got the guys wanting to go to the action movie and the women want to go to the comedy. But that's the nature of the beast. So hopefully this gives you an idea of the different type of frequency distributions you need to know and what a stack bar graph looks like. The last section, 10.4, is really just analyzing these tables and graphs and making conclusions and decisions about the data. There won't be a video for that, but you can practice that in the book and with your teacher. Hopefully it all goes smooth. One more thing, just to remind you, stack bar graph based on percents. Make sure your stacks add up to the total. Okay? Relative frequency conditional distribution is conditional percentages. Each percentage based on its own personal category, whereas in a regular relative frequency distribution based off the total. You remember that, you should have no problem. Thank you.